Live from the Icebox Studio in Montgomeryville, Pennsylvania, it's the Bill and Corey Show!
I'm Bill.
And I'm Corey.
Hey, welcome back to another great episode of Bill and Corey Show. We got some big things to show this week, so we're looking forward to this. Hopefully we get through all the questions we want to get through.
There's a few of them, yeah. There's good ones this week. That's a good one.
Your weekly dose of tech support improv.
Yeah.
Okay. First question, I don't really have a question. A question was brought up about leak checking semiconductor grade panels. It's an inboard helium leak test. And well, actually...
you got it, or you want me to hold it?
Well, yeah, I'll show the panel first, and then we're going to wheel something else on here. So this is actually, I better not drop it because this.
Yeah, don't hurt it. It's for a customer.
This is getting installed in the cabinet, and it's going to get shipped out next week, so we can't use it for next week's show.
Just look how shiny it is.
It's great.
Beautiful.
You got to make sure you don't get the real bad glare on there. But yeah, we put these in. You put these suckers in cabinets, and they look great. They really do. So this is our semiconductor grade panel. It's got welded. It's micro weld T's in here. You got VCR fittings. I can't really point to them because I'm holding it up. You got these really cool valves that indicate open and close.
Oh,
which is kind of neat. Red
and actually, a little foreshadowing.
Yeah, that's another question coming up too. Yeah, so these are really high semiconductor grade, high integrity panels, and we do a inboard helium leak test on these babies, and it's really great leak test. So Corey's going to wheel out.
Yeah.
What we use here. It's going to take up the whole camera.
It's a hog.
There's our little, look at that big guy. That's our Vico leak detector. It's really kind of cool. It's got, you got to be one of our highly trained technicians to run these things. You don't want to let me run it. I'll probably break it. This pulls a really deep vacuum on the panel. And then we'll show in a little bit, you'll spray helium over the joints to show you how we do that.
This isn't to be used to like clean a carpet though, not that kind of.
No, it's not for a carpet. This is for semiconductor grade panels, really sophisticated. We actually have to get this thing calibrated. We have a guy come in and calibrate these things. You want to wheel it back out and show what we're going to do here? Okay. So this isn't hook up the helium, so don't do this at home. But they would, you'd set this up. You'd set that Vico up, and you pull a vacuum on the panel, and then you wouldn't hold it. You'd have it laying down. So you'd pull a vacuum on the panel, and then you'd spray some helium, and the detector would detect if it finds a leak. So you go.
Yeah.
You
So
check
it sucks the helium into the line.
Yeah. So it's it's incredible. So helium because it's small.
It's small. Hydrogen's smaller. Why don't we use hydrogen?
Well, that's not so safe.
The Hindenburg.
So yeah, so you'd spray it over the welded joints and anything that could possibly have leaks in it, and you just go over it, and it tells you if you got a leak and stuff. So the question was, if there was a huge panel, I couldn't bring it on here because it was too big, and it would take up the whole, bigger than a table. Lots of valves, lots of things going on, and you pull a vacuum on it, and you're not getting the vacuum down where it's supposed to be. So in that kind of case, you'd have to isolate sections of the panel.
Because not everything can take a vacuum on the panel. You want to
hold this up?
Yeah.
A little bit easier here. Yeah, so you pull the vacuum here, and then you would close off the valves. So you close off that valve first, check to make sure this is good. And then you'd kind of work your way through the panel. Yeah, we can put that back down.
Yep.
So you work your way through the panel. Start for the shortest section first, and then work your way through to see if it passes leak tests, and then you'll.
Now, this specific problem, was there something? There was an item on the.
Yeah. In this one, there was a ultra high integrity pressure transducer, but doing a little research, find out that can't handle it does not have the leak check spec. It's got a really good leak check spec, but it wouldn't be able to handle our leak check spec on that. So we had to isolate that in the panel. So it's a good point for leak checking is that when you do an inboard leak check, there's some things, like some pressure regulators, something like
This guy.
One of these babies, general purpose, that has a rubber diaphragm. Helium's going right through that guy. You're not even going to be able to pull a vacuum on it. So you can't, you could try to do an inboard on this thing, it ain't going to pass.
No.
So, and there's piston regulators, you're not going to have them be able to pass on that either because they got an O-ring seal. But there's other leak checking things, and they're still high. We do high integrity leak tests, but they won't pass this kind of leak test, but they'll be good for your application.
I just want to ask the question I think everybody's thinking. Now, can you use the normal stainless steel appliance stuff to keep this thing nice and shiny and clean, or do you have to get a special, is there?
Oh, you don't need to clean it. It's always going to be, just don't put your fingerprints
Well,
on
if you
it.
get we got to get their anti-fingerprint panels they do for stainless steel fridges.
No. Yeah, so we kind of beat that one to death. Okay.
Oh, here we go.
Oh, this one. This is a good question here.
Yes.
And this is back.
This guy.
I have a customer that I have guided to, the Matheson regulator, part number SEQ 18L580, right there.
There it is.
They were looking at purchasing many of these, but had a question on
I think it was over 100 as well.
yeah, it was many. It was a huge batch of them. But had a question on how failure would work on these regulators. It's really, failure doesn't work, but that's just that's their wording.
And it's the same for pretty much every regulator.
Can you help explain what that would look like? And we sent them, we have a statement.
A state, yep.
It talks about regulator failure.
Penned by the very famous Bill Staples right next to me. It's a great read.
Yeah, so we went, because we've had a lot of questions in the past about this, about regulator failure. So, and there's different ways they can fail, so I kind of...
Yeah, I mean, and the most common failure, and this is by far the one I get questions about the most, is creep. And I don't mean the song by Radiohead. It's when a particulate typically gets in between the diaphragm and...
between the valve and the seat.
The valve and the seat, I'm sorry. Yeah. See, even I have to look it up every once in a while. The valve and the seat. Yeah. And that particulate will allow gas to creep through it. And so you'll...
Creep the other way.
Oh, yeah, sorry. I'm used to looking at it this way. Allows it to creep through it. And then it'll slowly, you'll see the outlet, the downstream pressure, delivery pressure will slowly go up. In fact, I just had a switchover question from somebody where that was happening. They're like, we use it, we hook it up, it works fine for a little bit, and all of a sudden the safety valve goes off.
It's an old switchover.
That was an old, I'm just saying.
But yeah, so... yes, so creep, and there's many things that can cause creep. Now, we talked about
particulates. That's the most obvious, common one.
And then
corrosion, if you have a gas that...
Yeah, so you get corrosive byproducts.
Yes.
So if you have corrosive gases, it's a big concern.
Now, this one was interesting to me as well, the density of a gas.
Density of gas.
Big old molecule.
Atoms, but molecules. Depends on what you got.
I guess
so. Something like... hydrogen and helium might be able to sneak by a little bit across your seal.
Yes.
As we were just talking about.
Yeah.
Like your leak checking. You got a high integrity leak check, you're using the small gases, the light gases.
The small atoms.
Yeah, so if you're doing argon, less likely sulfur hexafluoride, you ain't gonna creep.
And then low differential pressure. So one of the things, if you're trying to regulate a gas from, say, 100 to 95 psig.
Yeah. Well, part of the way that the valve closes is by differential pressure. So the differential pressure is 5 psi. So you're not going to have as much of a closing factor. It's not going to smash in there as well as...
Yeah, I mean, diaphragm valves, that's how they use it to close really well, is they use the pressure from the gas as well to help close it. And there are a few other ones. A seal leak is when the gas leaks out of the seal and into the diaphragm.
Yeah, that's like if the bonnet was loosened.
Or in the bonnet, yes.
Yeah.
So they leak.
Yeah, the bonnet was loosened. There's a...
bonnet vent. This is when we get into our bonnet vent holes and why we have them. So if it leaks through there, the bonnet is not rated for pressure. So if it wasn't allowed to pass through, that would cause problems.
Yeah, we have a bonnet vent hole.
Bonnet vent hole,
So,
yep.
And,
right there. And then there's diaphragm failure as well. The ones that we're coming up on next are very, very rare and hardly ever happen. But the diaphragms are flexible, and for some reason,
they could fail.
It could fail. It could bend in a way that flexes it in a bad way, and it could cause the diaphragm to become disformed a little bit, and then that'll cause a failure as well.
Well, that might happen for one that you've had for a really long time.
Yes.
Or in this case, you got a rubber diaphragm; it could get brittle.
Well, diaphragm is typically 10,000 cycles. That means.
I go, sure, that number was right.
Yeah.
That was 100,000.
10,000 cycles.
Oh, 10,000 cycles. They have to be tested to 10,000 cycles for CGA
so when it's
E4.
Yeah, pressurized and relaxed.
So yeah, yes, they are tested for that. I thought it was 100,000. It's 10,000. That's why we have paper.
That's why we have paper. You can't remember everything. We're good. We're not that good.
And then the last.
And a total seat failure. This could happen. I guess a rubber diaphragm.
Well, no, that's the
seat.
The valve seat.
I keep screwing up this diaphragm.
What could happen is, it could happen probably most likely with a acetylene type regulator, where you get flashback. So you get a flame that propagates back. You could have that with acetylene, and then it would melt the seat.
And that's why we recommend flashback arresters with acetylene.
Yeah. Yeah. So or if you have a different regulator, you have a different regulator, and for whatever reason there's something that happens and your seat disintegrates.
Yeah. But it's almost unheard of. But it's one of those things that happen, and you have to account for it when doing a failure analysis.
Okay. Another question for Corey.
Yes.
Thank you for getting back. Oh, I love this question. It's cool. Thank you for getting back to me so quickly. Here's a picture of the damaged valve. Want to pop the first picture up there? There you go. I'm assuming it might have been what you said with the operator thinking it was closed when it was actually fully opened at first. This valve has been in this state possibly for several years before I came upon it. So I can't say for sure exactly how it was damaged. What I can see now is that the knob has come off. I don't know where it is. And I think the last user might have tried using pliers. I keep turning it instead of, because the remaining part of the valve is pretty damaged and threaded. I can't seem to get it turn either way, which way now. So you can see this kind of...
This is actually a common problem where, and it's understandable a little bit. No, I mean, I'm not common.
Well, actually, you want to put up the next photo? And this is a little closer one. You can see straight on that the valve stem's kind of damaged.
Yeah,
you want to pop off the photo.
Become an oval instead of a hole right there.
So we're gonna.
So here we go. And sometimes, I mean, I get calls about this every once in a while where you got the valve closed, you open it, and people can't tell. That's why I was saying foreshadowing, because those valves tell you when you're open or closed. These ones don't really say if you're open or closed. Not like a quarter turn valve or anything. So people won't realize it's open, and they'll go, they'll keep stressing it out, and they're like, I can't get the valve open. That's because it's already open.
That's why you back off.
Oh, and I was just going to say that. So when you open a valve, you back it off a little bit, or else it could get stuck there.
Yeah. So when you turn it, and when you operate valves, always
even at home,
take your time.
Even at home.
Yeah, don't just like.
Just be nice to it. There, you're
nice
doing the right thing.
So yeah, that's why you back it off a little bit. So when you turn it, you go, oops, wrong way.
Wrong way. Yes. And so this one, you can replace it. Take the handle, take the sticker off. It exposes the screw. Take the screw out. Pop off the cap, and then here it is. This one.
They already did that though.
What's that? They already did that though. I'm saying if you didn't get that. And notice how this hole is still circular as opposed to oval like the one in there. And this is nice, smooth metal. And then you have this one that has...
Oh, yeah, actually, I could show you.
And you can actually take that piece off as well.
Yeah, so one thing, if you bust the handle...
that's simple.
Buy the handle, and we got a little kit. It's got the screw. Oh, it is a Phillips head. And a sticker, because that's important.
Well, no, you want to know which way to open and close it.
Yeah. And then...
Righty tighty, lefty loosey.
And then... Yes, if it's really
damaged, like the one in the picture.
You have to use a wrench. This is pre-loosened.
No, Bill's just that strong. Yeah. He doesn't like to brag about it, though.
You can buy a little kit here, and it's got the valve hand. It's just like the valve handle, but it's also got the stem. It's got a bunch of diaphragms. And it's kind of.
And actually, I've done this with a water valve in my home that was dripping.
I'll just swap up.
Oh, swapped out seats. Ooh, that's bad. Thank you. Yeah, swapped out, the innards, put new soft goods in there, and no longer having to hear that drip, drip of the faucet at night that drives you nuts.
And Corey, where can you find both of these?
Oh, store.mathesonthegas.com.
It's under valves.
Yeah.
It's kind of at the bottom. Probably should put it
We don't have a knob section.
No, we don't have a knob. No, we don't. Maybe we should. I don't know.
I mean, it's accessories, valve accessories.
Yeah. So that's
That's all the time I maybe have for today.
yeah, we're kind of run out of time. We'll skip the last question. We're going to cover that last question. We're going to do a
leftovers.
Leftovers with Bill and Corey. It's going to be podcast format. We'll probably do it tomorrow morning, like our little coffee break, and then we'll upload.
Or
that
tea.
too.
We can still do tea. We don't.
Well, it's called nobody calls it a tea break.
Well, we could pretend
Not
to be.
in this country. So okay, so
Ever since that party.
tune in again next week for another edition of the Bill and Corey Show.
Set your VCRs.